All right, class. In this video, we begin on page 3 of your section 4.3 lecture notes, part 1 on logarithmic equations. There are a couple of bases of logarithms that get their own special notation. One base that gets its own special notation is base 10. The logarithm with a base of 10, here I have log base 10 of x. The logarithm of base 10 gets its own special notation. It's called the common logarithm, and we denote the common logarithm of base 10 by just dropping the 10. So whenever you have the log of something and there's no base given, it's assumed that it's base 10. So log x is log base 10 of x. And so log of x equals y is equivalent to 10 to the y power is equal to x. The 10 is invisible on the log. So whenever you're using log base 10 on your calculator, look for the capital LOG button. That means log base 10. Another base that gets its own fancy notation is the natural logarithm. And in previous section, right, we learned about the number e, right, which is a special number in mathematics. Remember, the number e is equal to 2.718 to 3 decimal places, right? It's a special number like the number pi. And so a logarithm with base e gets its own special notation, and it's called the natural logarithm. And we denote the natural logarithm or log base e with ln. So ln of x, right, is equivalent to log base e of x. So whenever you see ln, right, you're taking the natural log ln of x, ln of anything, we're talking about log base e. So natural log of x equal to y is equivalent to e to the y power is equal to x, right? If we, instead of ln of x over here, we had log base e of x, then the corresponding exponential equation would be e to the y power is equal to x, okay? So whenever you see ln, right, we're talking about log base e. And so if you ever have to do a calculation with the natural log function on your calculator, right, look for the capital ln. All right, logarithms have properties, and we have 4 properties for regular logarithms and 4 properties for natural logarithms, right? They're all similar. Log base a of 1 is equal to 0, right? Log base a of 1, right, in any base is equal to 0, because in exponential form we have a to the 0 is equal to 1, and any non-zero number raised to the 0 power is equal to 1. Log base a of a is equal to 1 because a to the first power is just equal to a. So that's a true statement. Log base a of a to the x is equal to x, because when we go to exponential form, right, we have a to the x is equal to a to the x. That's a true statement. In 4, we have a raised to the log base a of x is equal to x. That's a true statement because in the definition of logarithms, right, we had a to the y is equal to x, and y is equal to log base a of x. So a to log base a of x is equal to x. The properties of natural logarithms follow from the properties of logarithms up above, but we're just doing them in base e, right, the natural logarithm. So natural log of 1 is equal to 0 because e to the 0 is equal to 1. The natural log of e is equal to 1 because e to the first power is equal to e. And the natural log of e to the x is equal to x because e to the x is e to the x. Remember, ln replaces log base e. And e to the natural log of x is equal to x. And that follows from the definition of the natural log function up here, because natural log of x is equal to y, is equivalent to e to the y is equal to x. So remember, y is replaced with the natural log of x, and we have e to the natural log of x is equal to x. And so that gives us property 4 down here. So let's demonstrate the natural log function going from logarithmic form to exponential form. Remember, ln means log base e. So the natural log of 5, which is equivalent to log base e of 5, is equal to 3 to the y, means e to the 3y power is equal to 5. Natural log of t plus 1 is equal to negative 1, means e to the minus 1 is equal to t plus 1. Natural log of x plus 1 is equal to 2, means e squared is equal to x plus 1. And natural log of x minus 1 equal to 4 means e to the 4th is equal to x minus 1. And now we can go in reverse order, okay, from exponential form to logarithmic form. So e to the x plus 1 is equal to 0.8. Remember, e is the base, x plus 1 is the exponent. So the exponent x plus 1 is equal to log base e of 0.8. Well, log base e is ln, so natural log of 0.8 is equal to x plus 1. E cubed is equal to y. E is the base, 3 is the exponent. So log base e of y is equal to 3. And so instead of writing log base e of y, we write the natural log of y is equal to 3. E to the x is equal to 2. E is the base, x is the exponent. So we have the natural log of 2 is equal to x, and e to the minus 1 is equal to 1 over e, right? E is the base, minus 1 is the exponent. And so the natural log of 1 over e is equal to negative 1.